For the most common biogas plants, processing the liquid in sewage treatment facility can add 134% to the total cost, which includes transporting raw materials and the construction, operation and maintenance of the biogas plant. Properly utilising the produced liquid fertiliser is the most important factor for biogas plants to be economically viable. Successful examples of biogas plants around the world are those which employ this practice. In Ogawa, we chose a small-scale, decentralised type plant to meet following objectives and conditions: limited budget, participation of residents, demand from local farmers for liquid fertiliser, and promotion of material recycling society. We designed a new plant with a fermentation tank of 13 cubic metres and the processing capacity of 200 kilograms of food waste per day. Cost for construction was about 8 million Japanese yen, approximately $70,000. It was financed by a loan from Artist Power Bank, materials supplied by the town administration, and additional funding and support by residents and other people. The construction of a new biogas plant started on February 6, 2006 in Iwata district of Ogawa. A foundation was laid to accommodate the 20 cubic metre capacity plant. The fermentation tank and liquid fertiliser tank were later installed on this foundation, and many residents participated in this stage of construction. As well as the installation of the fermentation tank, the main component of the plant. Local residents took initiative in planning, selecting the location, raising funds and constructing the plant. Now finally, the plant could begin operating. A workshop was organised and people learned how to operate the plant. Renewable energy facilities are like living beings. Kitchen waste needs to be added slowly, and the system requires constant monitoring to run smoothly. The fermentation tank is 1.3 metres in diameter, 7.8 metres long, and 13 cubic metres in volume. It can process 200 kilograms of food waste per day, coming from around 400 households. The town administration contributed to the project by supplying equipment such as food waste disposers. The plant is built on farmland for the convenience of farmers. The head of the neighbourhood, Mr. Nakajima, is anxiously waiting for the plant to begin operating.
匂いもそんなにあるもんじゃないし、この辺だって農家で牛飼ってる人もいるんでね。まあ、鳥も近くにもいますしね、鶏もやってる人いますから、そういう点ではあんまり気にはしてないですよ、日本の人は。ただ大量に出てくるようになれば使ってみようかという人はいます。
The raw material for the plant is food waste collected from participating households. Residents separate food waste, such as vegetables, from other garbage and put them in an 18-litre, 2-layer bucket at home. The waste is then put into designated 40-litre buckets at collection sites on garbage collection days. The buckets are then transported to the plant by contracted collection trucks. At the plant, waste is fed into the tank by residents, mostly farmers. Gas produced at the plant is used to heat the fermentation tank and generate electricity. Another important product from the plant is digested liquid fertilizer, very popular among local farmers. Mr. Yamada is a leading member of Wadachi Kai, an association of young local farmers. He utilizes the liquid as additional fertilizer for his eggplant crop.
一応液を10倍以上、だから20倍ぐらい少し薄めて、もしこの間風が吹いてこれちょっと被害を受けたんだけど、そうすると木が弱るんですよ。木が弱った時に緊急対策としては今度は葉水、葉面散布くれてやると復活するのが早いんで、でそれと。
Ms. Aizaki is an expert from the Saitama Prefectural Agriculture and Forestry Research Center. She tests the effects of the liquid fertilizer on vegetables such as lettuce and pot herbness at Mr. Tashita's organic farm in Yawata district. They divided the fields into sections and compared the growth of the vegetables by applying different fertilizers per section, such as the digested liquid fertilizer, compost or no fertilizers. The best result came from the section with appropriate amount of digested liquid fertilizer.